In the last video, we looked at an example of a hypothesis test involving a population proportion. This was the example about the households in Riverside County and the proportion of those households who receive federal housing assistance. And in the last video, we looked at step 0, which was to summarize the information and identify the point estimate. We looked at step 1, which was to state the hypotheses. And we looked at step 2, which was to verify the requirements for that hypothesis test. Step 3 is to test the hypotheses. There are 2 and sometimes 3 main approaches to testing a hypothesis. You won't have to know all 2 or 3 approaches. On the quiz or test or the homework, you can use any one approach that you prefer. But in this lecture video, of course, I'll show all approaches, and that way you can know about them and choose the one that you prefer. The first approach that we'll look at is called the classical approach, or sometimes it's called the test statistic approach. In this approach, you'll start by first sketching the normal probability curve and then using a table to find the cutoff value for the region that represents values that are unusual or significant for the study outcomes. We want to make a note that this is a left-tailed test. Left-tailed because the alternative hypothesis is for less than. Also, we'll make a note that alpha is 0.05. In the problem, it stated that we should be using an alpha of 0.05. This is the level of significance. And this also means that the area under the left tail is 0.05. That's the meaning of alpha. It's the area under a tail. Here's a drawing of that normal curve. I also drew one out right here. When you're working out these problems, you don't have to, but it does help out to draw out that normal curve. And then I drew the cutoff on the left tail. The z sub alpha, that is the cutoff z value. And then the area of that tail is 0.05. To find out what this z value is, we'll go to table 5c, which is a small table that's found at the bottom of table 5. And it looks like this. This is a left-tailed test. The alpha is 0.05, and for that, the z is negative 1.645. That's our critical value z. That's the cutoff value. It's like the boundary for that left tail, where the area under that tail is 0.05. The next thing that you would do if you're doing this approach is to calculate the test statistic. The test statistic for this hypothesis is a z-score. In general, a test statistic is a value that describes how far above or below your study's outcome is from the mean, and therefore it measures the significance or the unusualness of your study's outcome. Here's the formula for this test statistic. Remember that p sub 0 is the value of the null hypothesis. P hat is the sample proportion. So p sub 0 is 0.26 from the null hypothesis. N is the sample size of 400. P hat, we calculated that in step 0, but it's 0.2325. You would put all those numbers into the formula, and it comes out to negative 1.254. The last thing that you want to do is to determine whether this test statistic, negative 1.254, is inside the critical tail of the curve or outside the critical tail. So here's the curve again. Inside the tail will be considered, in this region, anything to the left of our cutoff. outside the tail would be considered anything in this region, to the right of the cutoff. If your test statistic is inside the critical tail of the curve, then that study's results are considered unusual and significant. And in that case, you would say that you reject the null hypothesis. And you would conclude, by default, that the study's evidence is supporting the alternative hypothesis. You could think of it as you are ruling out the null hypothesis. The null hypothesis was that the proportion is 0.26. The alternative was that the proportion is now less than 0.26. And in this case, if you reject the null hypothesis, you are ruling it out. You are rejecting that it's true, and by default, you are giving support to the alternative hypothesis. On the other hand, if the test statistic is outside the critical tail, if it's somewhere on this side, then that means that the study's results are considered not unusual and not significant, and you would therefore not reject the null hypothesis. And then, so that means that by default, that means that your study's evidence is not sufficiently supporting the alternative hypothesis. You could think of it as, in this case, your evidence just is not strong enough to reject that null hypothesis. And so you just can't rule it out. And if you can't rule out the null hypothesis, then that will have to stay as what's believed to be true. And by default, your evidence just is not strong enough to give support to the alternative hypothesis. So for this study, our test statistic was negative 1.254. And negative 1.254 is outside of the tail. The middle of this curve is 0. So negative 1.254 would be somewhere around here. So it's outside of that tail. That means that this study's results are considered not unusual and not significant. And we would say that we do not reject the null hypothesis. Alright, so there's another method to testing these hypotheses, and it's called the p-value approach. A p-value is a probability, and in particular, a p-value is the probability of getting the result of some particular study, or some result that's more extreme, assuming that the null hypothesis is true. The first thing you would do is calculate the p-value. And to calculate the p-value, it's easiest to do this calculation on a graphing calculator or some other type of technology. So on a Casio graphing calculator, you could take these steps to calculate the p-value. You want to get to this function called 1p. When you get there, the first thing it will ask for is prop, and what it's referring to is your alternative hypothesis. So you want to choose the inequality that matches your alternative hypothesis. Our alternative hypothesis was less than, so you want to choose less than. Then you'll see P0, that's referring to the value of the null hypothesis, which was 0.26. Then you'll put in the 93, which was the number of households who were receiving housing assistance, and then n is the sample size, which was 400. It's kind of similar if you have a TI 83 or 84. You would take these steps, you would get to the function called 1 prop z test, and when you get there, you put in the value of the null hypothesis, 0.26, put in the x, the n, and then this is similar, you would also put in the inequality of the alternative hypothesis. And again, it was less than, so you want to choose the less than symbol. When you do that, your p-value is calculated and it comes out to 0.1049. So what does that mean? Well, 0.1049 is the probability that 93 out of 400 randomly selected households who would receive housing assistance, assuming that the null hypothesis that p is equal to 26% is true. In other words, assuming that the proportion who receive housing assistance today is still 26%. The next thing you would do is, once you have that p-value, you want to compare it to the level of significance, the alpha. If your p-value is less than alpha, then that study's results are considered unusual and significant, and in that case you would reject the null hypothesis. And you would conclude that the study's evidence is supporting the alternative hypothesis. If your p-value is greater than alpha, then that means that the study's results are not unusual and not significant, and in that case you would say that you do not reject the null hypothesis. And that would mean that your study's evidence is not sufficiently supporting the alternative. So for this study, our p-value was 0.1049, alpha was 0.05, and so therefore our p-value is greater than the alpha. Since the p-value is greater than the alpha, that means that this study's results are not unusual and not significant, and that means that we do not reject the null hypothesis. The last step, step 4, is to state the conclusion. Usually you'll want to explain your conclusion in terms of the alternative hypothesis. And for a test or a quiz, you can usually state the conclusion in one sentence. And oftentimes, I'll just use the same sentence that's used in the problem that's describing the alternative hypothesis. So here's our conclusion. We do not reject the null hypothesis. That's what we concluded either way when we tested the hypotheses. That means that there is not sufficient evidence to conclude that the population proportion of households in Riverside County who receive federal housing assistance has decreased since 2015. So this whole phrase right here is the alternative hypothesis. And in effect, I've just said there is not sufficient evidence to conclude that the alternative hypothesis is true. So our evidence is not supporting the alternative hypothesis. Alright, that'll conclude our first example from section 10.2. In the next videos, we'll take a look at a few other examples.